Hello everyone, I'm Chavan. This is my project partner.
Hello everyone, I'm Neha.
We have designed a smart wheelchair for disabled people with mobility impairments.
Our proposed smart wheelchair works on two modules for its functioning. The first module works on accelerometer. The second module works on biosignal like electroencephalography.
Now let's see how the smart wheelchair operates with the first module, which is accelerometer. We built an Android application in which there is a start and a stop button. There are also 4 arrows pointing in left, right, forward and backward direction. These arrows are orange in color by default, as you can see in the screen. These arrows will glow green in color to indicate in which direction the wheelchair is moving at the given instant of time.
The user input captured from the Android mobile is then sent to the cloud. Here we are using Google Firebase. This data stored in the cloud is then pulled in real time in MATLAB terminal, where the further processing of data happens. After the data is processed and analyzed, we can see the outputs through glowing arrows in real time. We included accelerometer as a backup system, but our second module, which is also our main module, is driven by biosignal. Now, moving on to our second module, we worked with EEG, which is electroencephalography. We are using NeuroSky EEG headset to acquire the brainwaves. Some of its technical specifications are 12-bit raw output spectrum ranging from 3 to 100 Hz, sampling rate of 512 Hz, automatic Bluetooth pairing. This NeuroSky headset gives a variety of processed as well as raw brainwave signals. First, we get a whole raw brainwave spectrum. Then we get EEG power spectrum signals such as alpha, beta, gamma, theta and delta. We also get classified signals such as attention, meditation and eye blinks. Our work here is divided into two parts. We are going to use classified signals and power spectrum signals to operate our wheelchair. Talking about our work so far, we have designed a code which takes classified signals such as attention, eye blinks to increase, decrease, start or stop our wheelchair.
Specifically with attention signals, our user is able to control the speed of the wheelchair. We get attention signals that ranges from 0 to 128 from the NeuroSky headset. We take 50% value of this signal, which is 64, to set as threshold to increase the speed of the wheelchair by 1 units. Then we take 75% value of this signal, which is 96, to set the threshold to increase the speed of the wheelchair by 2 units. Now coming to eye blink signals, this is what we have implemented. NeuroSky headset gives eye blink signals ranging from 0 to 128. 50% of this range, which is 64, is set as threshold. Every time when the signal crosses this threshold, the counter value is increased. When the user makes 2 consecutive eye blinks with a gap of 1 second, the counter value is reset and the wheelchair's actuators are stopped or started accordingly.
Now coming to power spectrum signals. Currently we are working on power spectrum signals such as alpha, beta, gamma, theta. We are going to do visuomotor imagery, which involves mentally visualizing the performance of motor tasks. We went for this option because motor imagery stimulates areas of brain to activate those actual movements during daily activities. Let's quickly see a short MATLAB demo video of how our wheelchair would work with accelerometer.
So now I have run the program. At this point of time, as you can see, I have to open the application and click on the start button. So once I start, you can see the graphs will be plotted on the real time and the intents will also be displayed on the command line. So the graph which you are seeing on the right hand side is plotted in real time. The data is being captured from the cloud.
So that's our work so far, and these are some of our references. Thank you guys. Thank you for your time.
Stay safe.